Hi everybody, today we are going to study our next point, trigonometric equations. Now first we define a trigonometric equations. Equations involving trigonometric functions of a variable are called as trigonometric equations. Okay, now we have to find its solutions. There will be two parts of solution, principal solution and general solution. In principal solution, the solution of a trigonometric equation for which 0 less than equal to x less than equal to twice pi are called the principal solution. That means the solution in between interval 0 to twice pi are called as principal solution. And general solution means the expression involving integer n which gives all solution of a trigonometric equations is called general solution. Okay, in that we define expression involving integer n, okay, which is known as general solution. Okay, so first we take an example. Now example is find the principal solution of the equation sin x is equal to 1/2. As we know that sine of angle is 1/2. Okay, so if you see the value of x is equal to pi by 4, which is 45 degree. Sorry, wait. Sorry, it is x is equal to, for x is equal to pi by 6, that means for 30 degree it is 1/2 sine pi by 6. Sine pi by 6 it is 1/2. Okay, so we know that sine pi by 6 is equal to 1/2, and also we know that in second quadrant all signs are positive. Okay, and in third quadrant tan and cot are positive, and in fourth quadrant it is cos and cos are negative. Okay, cos and its reciprocal are negative, which means it is a sec, okay, which is negative. Here sine and cosec is negative. So here it is 1/2 in first quadrant, which is positive. Okay, so it will be considered in a second quadrant. So we have to take an angle such that, so here it will be considered as sine of pi minus pi by 6. Okay, so here it which should be equal to sine of pi by 6. Okay, which means that sine of pi minus pi by 6 is sine of 5 pi by 6 is equal to 1/2. Okay, which is less than twice pi. Okay, so therefore you can say that principal solutions are x is equal to pi by 6 and 5 pi by 6. Okay, which is our required solution. Okay, here it is 5 pi by 6, it will lie in interval second quadrant. Okay, if you consider here pi plus pi by 6, it will be in third quadrant, but value of sine is negative, so it will be minus 1/2, and in fourth quadrant also it is negative, so we have to choose here angle such that it should be lie in a second quadrant only. So we have taken here pi minus pi by 6. Okay, as you know that sine pi is equal to sine 0. Okay, so here sine 0 value is 0, and sine, here we can write sine pi by 6. So sine a minus b is sine a cos b minus cos a sin b. Okay, so it will be 1/2 only, or here it can be write as sine pi by 6. Okay, now go to next example, as you will solve it in your homework. So for homework purpose find the principal solution of equation tan x is equal to minus 1 upon root 3. Okay. Oh, sorry, we will do it here only. In this we know that tan of pi by 6 is equal to 1 upon root 3. Okay, so here given that it is minus 1 upon root 3, so tan of, so you know that tan is positive in third quadrant. Okay, so you have first value of tan of pi minus pi by 6. Okay, in second quadrant, which lie in a second quadrant, which is negative, so which will be minus tan of pi by 6. Okay, so minus tan of pi by 6, tan pi by 6 is 1 upon root 3, so it will be minus 1 upon root 3. Okay, which is our first principal solution. And again it will be you have to consider in next value will be in fourth quadrant. So here you can consider tan of twice pi minus pi by 6. Okay, so here it is up to this angle is twice pi, total angle twice pi, and you have to subtract pi by 6 from that. So you can get minus tan pi by 6, which is equal to minus 1 upon root 3. Okay, so the principal solutions are x is equal to 5 pi by 6 here, first pi minus pi by 6, which means it is equal to tan of 5 pi by 6, and here it means that it is a value of tan of 11 pi by 6. Okay, and 11 pi by 6. Okay, which is our required solution. 6 pi 2s are 12, 12 minus 1 is 11 pi by 6. Okay, so which is less than again twice pi. Okay, now we know that as sin x is equal to 0 gives x is equal to n pi, where n belongs to z. Okay, which means that if you start from n is equal to 0, okay, for n is equal to 0 it will be sin of x is sin 0 is equal to 0. Okay, for next it is for n is equal to 1 it will be sin of x's value is sin x, we taking n is equal to 1, x as here n is equal to 1, it will be sin pi, so sin pi is again 0. For n is equal to 2, sin of it is twice pi, okay, which is again 0. But here for in this case the principal solution will be it is our general solution, x is equal to n pi, sin x is equal to 0, for x is equal to n pi, where n belongs to z is our general solution. Now principal solution of sin x is equal to 0, we have to find solution in between 0 and twice pi. Okay, so here principal solution will be in between 0 and twice pi, so here it is coming for sin 0 is 0. We know the condition for principal solution is 0 less than equal to x less than twice pi, which is less than twice pi. So for x is equal to 0 and for x is equal to pi. So this is our principal solution for sin x is equal to 0, and it will be general solution. Sin x is 0 for x is equal to n pi, where n takes any integer. Okay, so here for n is equal to 3, sin it is 3 pi, it is again 0 and so on. Okay, now also we know that cos of x is equal to 0 gives x is equal to twice n plus 1 pi by 2, n belongs to z. Okay, so in this case also for n is equal to 1, cos of here n is equal to 1, if you put n is equal to 1 it is 2 plus 1. Okay, so sorry, for n is equal to 0 it starts from n is equal to 0, so here for n is equal to 0 it is a 0 plus 1, which means pi by 2, cos pi by 2 is 0. For n is equal to 1, it will be 2 plus 1, which is 3. So cos of 3 pi by 2 is equal to 0. So for this, principal solution is x is equal to 0 and 3 pi by 2, which lie in interval 0 to twice pi. Okay. Now after that, if you consider n is equal to 2, we will get cos of 2 plus 2 into 2 is 4 plus 1 5 pi by 2, which is again 0, but it is not a principal solution. Okay, because it is greater than twice pi, which you can write in a term as a cos of 2 pi plus pi by 2. Okay, cos of 2 pi plus pi by 2. So here it is greater than, because we are adding 90 degree in twice pi, so that we can get cos of 5 pi by 2. Okay, which is greater than twice pi angle. Okay, so it will be not in our principal solution, but it is in our general solution. Okay, this is our general solution. Okay, now consider the theorem. For any real numbers x and y, sin x is equal to sin y. If sin x is equal to sin y, implies x is equal to n pi plus minus 1 raised to n y, where n belongs to z. Okay, so in proof, you can consider as given that sin x is equal to sin y, which implies that therefore sin x minus sin y is equal to 0. Okay, now as we know that sin x minus sin y, we know that sin y is equal to twice cos of x plus y upon 2 into sine of x minus y upon 2. Okay, this is the formula related to sin x minus sin y. Okay, so we shall use in this case, so it can be written as twice cos of x plus y upon 2 into sine of x minus y upon 2 is equal to 0. Okay, so which implies that, or which gives, here you can write this term. So here 2 is not equal to 0. Okay, so it only remains to check whether cos of x plus y upon 2 is equal to 0 and sine of x minus y upon 2 is equal to 0. Okay, so we have these two relations. So from this equation you can write cos of x plus y upon 2 equal to 0, or sine of x minus y upon 2 equal to 0. Okay, now as we know that here in above we have written that for cos x is equal to 0, here we have x is equal to twice n plus 1 pi by 2, where n belongs to z. Okay, so we have an condition for a cos x is equal to 0. So here angle is x plus y upon 2 equal to 0. So here we replace x by x plus y upon 2. So for first you can write x plus y upon 2, it is equal to twice n plus 1 pi by 2. Or also you know that sin x is equal to 0 for x is equal to n pi, where n belongs to z. Okay, so for this also it can be written as x, here x is x minus y upon 2, so x minus y upon 2 is equal to n pi. Okay, so here denominator is same on both sides, so it can be written as x plus y. It will be cancelled from both sides. It will be remains only twice n plus 1 pi. X plus y is equal to twice n plus 1 pi, or in this side x minus y is equal to twice n pi. Okay, so we write the values of x as x is equal to twice n plus 1 pi minus y, or you can write x is equal to twice n pi plus y. Okay, so here if you see that coefficient of pi, it is twice n plus 1, which means that if you know the definition of odd, it will be always an odd number. Okay, twice n plus y, for any value of n belongs to z, it will be an odd number, and here it is an even. Coefficient of pi in second equation is an even number. Okay, so here it can be written as x is equal to twice n plus 1 pi. Here second minus 1 minus y here. So I write here plus minus 1 raised to twice n plus 1 y. Okay, as you know that if a negative power is an odd number, it will always be a negative. So here we write in a form of, here coefficient of pi is twice n plus 1. So here write minus 1 raised to twice n plus 1. Here these two terms will be same. Okay, so x can be written as twice n plus y pi plus minus 1 raised to twice n plus 1 pi. Sorry, y. Okay, so here this term indicate it is an odd number also. Okay, or you can write here for this also as a same pattern. It is twice n pi plus minus 1 raised to twice n pi. Sorry, y. Its coefficient is y. So here y. As you know that minus 1 raised to any negative raised to even is always positive one, and negative 1 raised to odd is always negative, minus 1. Okay, it is plus 1 or it is minus 1. Okay, so here for these two equation you can say that it is for odd and it is for even. So from these two you can write it as, or combining these two result, we get x is equal to, so here it is same pi and y. Here it is pi plus y. Okay, so it can be written as n pi plus minus 1 raised to, coefficient of pi is n, so here write raised to n y for or where n belongs to z. Okay, okay, you understood it? So if here n is odd or even, it will satisfy the condition, both conditions. Okay, here we have proved it that it satisfies for odd also and even also. Okay, or you may consider as coefficient of pi is twice n plus 1 plus minus 1 raised to twice n plus 1, and it is also in a format of twice n as a power of plus minus 1 raised to twice n. Okay, so here we replace it by n. Okay, so it will be n pi plus minus 1 raised to n y, where n belongs to z. Okay, so which is our required proof. Next theorem is theorem number 2. It is straightforward. So for any real number, x and y, cos x is equal to cos y implies x is equal to twice n pi plus or minus y, where n belongs to z. Okay, so in this proof you can consider as given that, or if cos x is equal to cos y, it can be written as, therefore cos x minus cos y equal to 0. Again we know cos x minus cos y is equal to, formula is minus twice sine of x plus y upon 2 into sine of x minus y upon 2. Okay, so here it can be written as minus twice sine of x plus y upon 2 into sine of x minus y upon 2 equal to 0. As our right side is 0, so it will be considered as only sine of x plus y upon 2 into sine of x minus y upon 2 equal to 0, because minus 2 is on right will become 0. 0 upon minus 2 is 0. So here from this we can write it here, sine of x plus y upon 2 is equal to 0, or sine of x minus y upon 2 equal to 0. Okay, here again we know that sine x is equal to 0 gives x is equal to n pi, where n belongs to z. Okay, so here sin x plus y upon 2 equal to 0, which means that from this you can write x is equal to n pi. So sorry, here x is x plus y upon 2. X plus y upon 2 is equal to n pi. Or for this its solution will be x minus y upon 2 is equal to n pi. Okay, which is general solution. Sin x is equal to 0, x is equal to n pi is general solution of sin x is equal to 0 for n belongs to z. Okay, which gives us x plus y is equal to twice n pi, or x minus y is equal to twice n pi. Okay, so x will be equal to twice n pi minus y, plus y on RHS will be minus, or x is equal to twice n pi plus y. Okay, so from these two equations you can directly write x is equal to twice n pi. Here it is for plus minus sign, so it will get a 2 solution plus minus y for n belongs to z. Okay, which is our required proof. Now next theorem is prove that if x and y are not odd multiple of pi by 2, then tan x is equal to tan y implies x is equal to n pi plus y, where n belongs to z. Okay, here condition is given that it is not odd multiple of pi by 2, because tan pi by 2 is infinity. So here we have to consider, or we do not consider odd multiple of pi by 2. So here given that if tan x is equal to tan y, which implies that, or we can write tan x minus tan y is equal to 0. Okay, so as we know that tan x minus tan y can be written as sin x cos y minus cos x sin y upon cos x cos y. Okay, is equal to 0, or you can write sin x upon cos x minus cos x upon cos y upon sin y upon tan cos y, and you taking reciprocal LCM, you can write in this way. Okay, so I will write here sin x upon cos x minus sin y upon cos y equal to 0. You have to take LCM. So as we know that cos x in LHS, this is equal to 0, which means that our denominator should not be equal to 0. If denominator is 0, so it will be infinite solution. Okay, so here we consider that it is not equal to 0, so sin x cos y minus cos x sin y equal to 0. As we write here, cos x cos y is not equal to 0. Okay, so as in statement only we have considered an odd multiple of pi by 2. So cos pi by 2 and cos x and y, cos is not equal to 0. Okay, so it only remained to check whether sin x cos y, its numerator equal to 0. So sin x cos y minus cos x sin y equal to 0, which means that sin of x minus y is equal to 0, which is formula of sin x minus y. Okay, now here you know that, or we know, sin x is 0 gives x is equal to n pi, where pi belongs to n belongs to z. Okay, so here x minus y equal to x minus x is equal to 0, and x is x minus y is equal to n pi. So which implies that x is equal to n pi plus y, where n belongs to z. Okay, so which is our required proof. There is no any other condition here. Okay. Now consider the example. Find the solution of sin x is equal to root 3 by 2. As we know that sin x is equal to root 3 by 2 is equal to sin pi by 3, and which is also equal to, which will be present in second quadrant, that means equal to sin pi minus pi by 3, which is equal to 3 minus 3 pi minus pi, which is sine of 2 pi by 3. Okay, so here in this example you can say that hence sine x is equal to sine of 2 pi by 3. Okay, which gives, as we know that for sine x is equal to sine y, x is equal to, so here sine x is equal to, we consider sine x is equal to sine pi by 3, not 2 pi by 3, because first value. Okay, so which gives sine x, which we have know that in first theorem we have proved that sine x is equal to sine y, then x is equal to n pi plus minus 1 raised to n y. Okay, so here value of y is pi by 3. Okay, which means 1 into pi divided by 3, n is equal to 1. Okay, so you can write x is equal to n pi, general solution, it will be plus minus 1 raised to n, which is minus 1 raised to n. Now here it is value of y is pi by 3, so it is pi by 3. Okay, where n belongs to z, which is our general solution of the sine x is equal to root 3 by 2. Okay, if you consider next example as cos x is equal to root 3 by 2. Consider cos x is equal to root 3 by 2. Okay, so in this example here cos x is equal to root 3 by 2 is equal to, now here angle will be equal to, so for x is equal to pi by 6, means cos 30 degree, pi by 6, it is root 3 upon 2. Okay, so we have a second theorem, cos x is equal to cos y, then x is equal to, x will be equal to twice n pi plus or minus y. Okay, where n belongs to z. Okay, so here we can write cos x is equal to cos of pi by 6, which means value of y is equal to pi by 6. Okay, so from this theorem you can write x is equal to twice n pi, which is our general solution, plus minus y is pi by 6. Okay, which is our required solution. Okay, if you consider an example of cos of x is equal to minus 1. Okay, so first value for n is equal to, for first where it is minus 1, so you can write cos of x is equal to minus 1 is equal to cos pi angle. Cos pi is minus 1. Okay, so for this here general solution will be x is equal to, y is equal to pi, so x can be written as twice n pi plus or minus pi. Okay, which is our required solution. Okay, for homework you may solve, you have to solve the first example, sine x is equal to 1 upon root 2 minus 1 upon root 2 consider. Second example as a cos of x is equal to minus root 3 by 2. Next, third example, tan x is equal to 2. And as a fourth example, you have to solve tan 2x is equal to minus cot of x plus pi by 3. Okay, so for homework you have to solve these 3 or 4 examples. For fourth example you have to convert this in tan. So for conversion you know that a formula minus cot is equal to tan of pi by 2, tan cos theta is equal to tan of pi by 2 plus theta. Okay, so here theta is this term, so it can be written as tan of pi by 2 plus x plus pi by 3. Okay, and after that you have to solve this example. So for today we will stop here. Thank you.